Hello, everyone. Welcome to this web scraping tutorial. Maybe if we could switch the view on our camera, we'd be able to see me who's speaking right now. There we go. Nice. Excellent. Thank you. So hello, everyone, and welcome to the web scraping tutorial, which is part of the Measuring Progress Learning track. My name is Sophie Callahan. I'm a Knowledge Management Officer with the GLF. And one of my focuses is on GLF's own monitoring and evaluation. So my colleague, Greg McGann, who will be providing this tutorial in just a moment that you are tuning in for, and I are the coordinators of this learning track. Many, many thanks to you guys who have been following this learning track. It's been really fun to engage with you in the social group as well as in our structured networking style cocktail hour that we recently had. We hope that you found the sessions that we've had the past 2 days to be enriching, and we're looking forward to continuing to connect with you through our track social group, as well as in the next casual structured networking style measuring progress coffee hour that's being held later today. That will be held from 4 to 5 p.m. CEST, but Huva will tell you what hour is relevant for you. If you haven't been following this track, but you would be interested in connecting with others who are curious or passionate about topics related to measuring progress towards, for example, climate and biodiversity goals and other sustainability objectives, we encourage you to follow our social group. The name of that is Learning Track: Measuring Progress, and you can find that by going to the Community tab in Huva. And Huva will be open as a platform for a full year after this conference is done, so you can continue engaging there even afterwards. But in addition to that, there's a possibility upon participant interest that we will also open an online community of practice on this theme and develop that with the community that's interested. That would be hosted on the platform of the GLFX initiative, similar to the communities of practice on finance and value chains and food and livelihoods. If you would be interested in taking part in that ongoing online community of practice on measuring progress, please let us know in the social group, or you can let us know in the chat function here. Now, to this tutorial. The Global Landscapes Forum is the world's largest knowledge-led platform. And with this tutorial, we're hoping to provide you with new practical skill, a tool in your tool belt that can help you collect and analyze information from websites so that you can cultivate and share your own new knowledge. The internet is increasingly full of unstructured text data, and web scraping is one essential skill for making sense of this vast world of information. In short, web scraping is a method of extracting and restructuring information from web pages. And in this tutorial, our very own Greg McGann, who works with the GLF digital and knowledge teams, will introduce you to the concept of web scraping and will also walk you through examples of how you can apply this method practically step by step. He will be using R, which is the most common programming language for statistical analysis, and he'll use the interface of RStudio. The script to this tutorial is available for download on GitHub. And I have shared the link to that in the chat. So you can feel free to check out that script so that you can follow along, or just to check back in case you missed something. There's also a slight chance, we're hoping this doesn't happen, knocking on wood, that if at some point the stream becomes slow or if the video quality becomes slightly grainy, it may be a little bit difficult to read the lines of code that Greg will be referring to. Thankfully, the script also has you covered for this, so you can check back there if you didn't see something clearly or if you just want to have a backup reference. So we pre-recorded Greg's tutorial just to make sure that connectivity issues were as low of a risk as possible, and so that you wouldn't miss any crucial information if a step in this tutorial were for some reason to get cut off. So we will be streaming that here shortly. This tutorial lasts about 30 minutes. And during the tutorial, what I would ask from you is to please post any questions you have in the Huva Q&A function. During the tutorial, I will be collecting your questions from there. And then after the tutorial is through, Greg and I will meet you back here and we will have a short Q&A. You can also post questions in the chat, but it might just be a little bit easier for me if you use the Q&A function. So yeah, without further ado, let's get this tutorial started. Thank you so much again for joining, and I will see you in a bit. So if we could roll the tutorial, please.
Hi, hello, welcome. Greetings. This is the Global Landscapes Forum Bonn 2020 Digital Conference, and this is the web scraping tutorial for the Measuring Progress learning track. I hope you enjoy this tutorial. It's been put together with the objective of helping us broaden knowledge sharing by helping you find it yourself. There's been a step change in the internet since the advent of user-generated platforms like YouTube, Facebook, Flickr, and any number of blogs. And that has produced an enormous amount of unstructured data. And web scraping is a tool we can use to grab some of that data and break it down, analyze it, and produce useful insights for ourselves. And what I hope to do today is give you the simplest possible introduction so that you become confident in getting a little bit of information from the web pages that you read every day. And hopefully you'll go on from this tutorial to explore web scraping and integrate it into your work and your daily life. It really is that simple. It doesn't sound exciting, but I'll do my best. Okay, let's jump right into it. What is this? What is this you're looking at? It's R. It's a statistical programming language that is used for, it's a statistical computing language that is used primarily by data scientists. So whereas a language like Python might be used by developers, R is mainly confined to those who are interested in studying applied statistics in whatever field. I mean, from econometrics to accounting. People use R across the world, and it's one of the fastest growing languages in which to conduct this sort of research. Okay, so what we're looking at right now is RStudio, which is an addition to R, which makes it the interface more compatible and hospitable to people. Instead of just having a simple console, you have this area in which to write your script. You have your console. You have your list of data, as you can see here on the right. It doesn't come with this. This is my data. And then you have your packages. And other things, files, plots, help, viewer. This is like your catch-all. We're going to be using some packages. And for those who don't know, you can just download R free from the internet. It's open source, which is one of the reasons it's so popular, actually. Okay. So you want to get R from this website, internet permitting. Okay. You can find this for all of your operating systems. It will be downloadable to Mac, Windows, etc., Linux. Here, and then you want to follow that up with downloading RStudio. Trust me, it's a lot nicer experience. Okay. You can see the website is just rstudio.com. Okay, brilliant. So let's jump right into the business of web scraping. The package we're going to be using, and by the way, as I mentioned, packages, they're like downloadable programs you can use for statistical specific statistical operations. So web scraping is one of those. And so what we want to do is we want to type in, if I can spell it correctly, install packages are best. So when you're writing a command, in the top left, just type it, install.packages. It should then open parentheses automatically. If it doesn't, just type it makes no difference. And then open speech marks, type in rvest, okay? And then highlight it for clarity's sake, and then run it. I already have rvest, sorry. So it's not going to work because I already have it. But that's how you do it. You highlight it and you press this run, okay? Run. Okay. So it is doing something, as you can see. It's reloading it and updating it. And here you have your list of packages. So if you've successfully downloaded your package, it will be here. You can see rvest. Now that you have your package, that's not enough. You need to do one more command, which is library. Similar, library, parentheses, open speech marks, and then put in rvest. And you want to run that as well. Okay, so now we have our programs. We're equipped to do this simple task, but it can be a bit intimidating. Now we need our article. So for the purposes of avoiding copyright, I'll use my own blog. And whatever you choose. For this, we're doing a blog because it's the simplest possible thing. And just copy the URL. Put our URL there. Just paste it. So now we have our URL. Great. And what we want to do now is our first sort of is our first step towards web scraping. We want to define our object, which is basically just saying, well, what are we going to name this thing? What are we going to name this data we're going to be drawing from? We're going to get the information from the internet, put it in an object. So let's call it sample blog 1. This is important. Name it whatever you want. Then put this sort of arrow, which is a less than sign, then a line. And then you want to write this command, read HTML. It will probably predict it, but you don't have to predict it. You can just write. You can just type this, read HTML, open parentheses, open speech marks. Take your URL, put it inside that, make sure it's all on one line, just for clarity's sake. Now, run it. What I'm doing is I'm pressing Command Enter at the end of the line, which runs it as well. It's a shortcut for running it. Do we have it? Yes, we do. If you've successfully uploaded it, it will be in the environment here. Sample blog 1. Okay, great. Okay, so now we have our sample blog. What do we do with it? Well, you can see here the key to this whole conundrum is HTML. Read HTML. What is HTML? Well, I'm glad you asked, because it's the key to all of it. I've got here a little explainer of what HTML is, it's basically the back end of the web page. And let's look at it on our article. I've just left-clicked on the page. You see, if you click on the wrong bit, it probably won't do it. So look for an empty space, okay? Left-click on an empty space, and you want to have Show Page Source. It might not show. This menu might come up after you left-click, and it might not have that Show Page Source. This was a great mystery to me when I first did this. So you want to go to Safari, Preferences. You've got your tabs, Advanced. Go to Advanced, and tick Show Develop Menu in Menu Bar. Great. Now you should have it. Show Page Source. Now we face what looks like a truly fearsome lot of nonsense. But this is actually your great friend, because this is HTML applies a structure to what would otherwise be unstructured data. And we're going to use the structure that HTML imposes on the text to do it right, to get the information, to do our web scraping. And we'll be using this, essentially. Become familiar with this. It looks like it looks very intimidating, but actually it's deceptively simple. This is a basic expression of we have an element. And the main thing you want to know about it is this tag. We in RVS we call tags nodes. It's not strictly true, but just tag. You won't find the word tag, but the command will be node. But you want to look for these tags, which are in blue here, and they'll be actually differentiated by color in the HTML, usually. So you want to look. The way to find it is it's actually sort of enclosing the text, like parentheses, and it will have this. It will be at the front, and then it will be at the end with a slash, and then repeated. So you want to look for that pattern. Well, let's just find one. Find an example. We have our HTML here. It's not much you want here. We're just doing a bit of exploring because to demonstrate what it looks like. You can see here that here is an expression. A. Can you see this? A and then A there, slash A. A slash A. Okay, great. So this is something that we can do something with, right? Okay. We do have a way of getting around this. Which you can explore afterwards. And we call it Selector Gadget. If you download Selector Gadget and put it into your bookmarks up top here, that's how you do it in Safari. I'm not quite sure how you do it in Windows, but actually it's more or less the same. Selector Gadget allows you to look at, to very, very quickly find, let's just find the HTML, the relevant HTML. Internet permitting. Okay, So let's just press it, select a gadget. It's loading. And let's say you want this. P. As you can see, select a gadget is a very efficient way of finding what you need. It's actually providing the relevant HTML here. This is a more advanced level, so we're not going to do it today, but just so you know, we don't have to go around looking in the HTML like we're doing right now every time. There are more efficient ways of getting the information you want. We're just doing a little bit of exploratory analysis. Exploratory HTML crawling. Okay, so we found our expression that we know. This is what we were. This is actually another one, but this is what we were led to expect. A and A at the end. So let's enter our first command. And I'm going to show you just the format of our arguments, which is what we call them, arguments, presumably just to be obtuse. So you'll notice that we have a sort of this funny symbol, which is percentage greater than percentage. It just means that this is all part of one. The next line is part of the same argument. You can see it's indented. Make sure it's indented. If it's not indented, you did it wrong. Trust me. It's okay. Let's put in HTML, and we're going to put nodes, because that's what we mean when we say tags. That's what we mean. We mean nodes. Rightio. Got nodes. So which node do we want? Well, I'll let you in on a secret. We don't actually go through the HTML and look for the nodes. We actually have, most of us have a list of the common nodes common tags, that we want and are useful for our research. So in the interests of finding out whether we've messed up, and this is actually the article we want, let's put in the most obvious thing, which is title. Check we've got the right title. And we want the text. Okay, so highlight all of that and press run. Okay, title. It is the right title, so we're not mad. And we're on the right track. It's important to establish that. Okay. So now we have a pretty good argument, and this is the argument we're going to use throughout this tutorial. So once now you've learned this, you've learned it all. We just need a new tag. And we're not going to use A yet. That's what we saw in our little equation. We're going to use P. Why, you ask? Because P, if we go down to our text, you'll see that P here, can you see this? Okay. There's your paragraph, and it's enclosed by, at the beginning, you can see it in purple, P, at both ends. That just means paragraph. Okay? So we want to pull our paragraphs. We've got our titles. We've got our title. Now we want to pull up our very simple blog, just titled paragraphs. And it's not going to distinguish between just one line written in my bibliography and the rest of it. So, huzzah, we have another argument. And we want text again. We just want our paragraphs. We just want our information. So for clarity's sake, this is what we're doing. These are all the lines we're doing. And we're going to run that. Fantastic success. As you can see, this is the bibliography. And here we have the actual body text. So now there you have it. We have title, text. Congratulations, you're now a web scraper. So we've established this. that you can pull text. And if you have a blog, you want to do some research on it, or you just want the text, you've got the URL, you've got the title, you've got the way to pull the paragraphs. Success. There's one other thing which I'm going to add, another argument, which is our old friend, A. Why are we adding A? Because A is links. So why are links important? Well, actually, that's the nature of the internet, web, the World Wide Web, as it was being conceived in some R&D department in the Navy in the US in the 1960s or whenever. It was just construed as a linked pages, and in fact, that's how the most dominant website on the internet, Google, came to be so dominant, because it uses an algorithm called PageRank, which essentially ranks pages by how many things are they linked to, and how many pages link to them. So where is it in the web, in the network? And actually, that's the first thing it does. And the second thing it does is it tries to quantify to which pages is this page connected. Are they influential pages? Is it connected to pages which are themselves connected to lots of different other pages? So, and anyone who's familiar with marketing will know that this is how we determine the quality of links. So, when we have our page, this is something we desperately want to do. We want to find out about the links to it. Perhaps you're running this on every page of your website. Very easy to do. You just give your URLs. We would have a more efficient way of doing it, but it's suitable for us to just think about it as having your URLs and then running this. You can then work out how connected they are to each other. So in your internal network, what's being supported and what isn't, and where is everything placed. So if you have an internal blog, is it being linked to things? Is it promoting things? Are people coming to it from inside your website or outside? These are all really important things to understand for your business, for your organization. So we want A. A is important to us. But here's something different. Previously, we were just finding the content, the text. So we put HTML notes, tag, whatever, and then HTML text to get this content. But now we don't want that, because we don't want to just get contact us. Contact us is useless. We want contact.html. We want to find the link. So we want attribute. If you see here, attribute. Okay. It's going to make more sense when I do it. So let's switch that to attribute. Because as I just said, we're looking for the attribute. Switch this to A. So we're looking for URLs, tags, and other things which we can use to sort of build the network of the site. And for this operation, what we need is this. The attribute name searches the attribute. So for this, what we want is the href, if you see here in red. Href. Href. That's what we're running. Huzzah. Good list. Good list. These are all the links on the blog and the tags. Okay. Now, if we had more time, we would be cleaning this data up. We could say we could add another line which would say exclude everything that doesn't begin with HTTP. So so no tags, just straight URLs. We could easily do that, but we're not going to because we don't have time. But what we've provided here is some very, very simple code, the most simple code possible on the most simple blog possible. But beyond the no illusions, this is powerful because, for example, let's say you wanted to perform this. Let's say you had the URL of a website, a news website, let's say CNN, and you perform this. It said CNN, read HTML, CNN homepage. Then you had your CNN homepage. You replace this with CNN homepage. Then you put it here, and then you change your node to the titles, whatever are called the titles in the CNN homepage, whatever the tag is. And remember, that's what's enclosing it. That's what's going to be enclosing the expressions. And then you print the text. You might need to add an attribute, but try it first. And what you could do is you could run that on R, simple click, every 5 hours without even going to the website. And what would you find? You'd find a list of the headlines. So let's say you don't have time to just go, sort of click through the website. You just run this, and let's say you have 10 lines of code and you have 10 websites. You can pull all the headlines. Never have to read them again. You just have your R. It reads in the HTML. It grabs the headlines. Voila, you're informed, or have the appearance of being informed. So this is a very powerful package, Rvest, and I do hope this has been useful to you. There is going to be a Q&A after this. If you do want to ask any specific questions, my website has this problem. I want to get this information. Just put it in, and we will find a way, because it's problem solving on R is difficult, but it's always possible. So do let me know. Thank you for joining us, and I hope you enjoy the rest of the conference. Thanks.
All right. So I'll wait till we're all here together, two of us. Let's see. Good. Okay, so hi, Greg. Thanks so much. I was personally really excited for this tutorial because web scraping is honestly a new tool or method for me to use as well. So yeah, thanks so much for sharing your time and expertise with us. Yeah, because it's a new skill for me, apologies if any of my questions are introductory, you could say. Yeah, so maybe just a first question is more of a sort of housekeeping or logistical question. There were a few questions that asked if this session is being recorded and if if our participants can go back to view it again, if they can have access to this tutorial later.
Yes, it is being recorded and it will be available on the GLF YouTube page and in our on our knowledge page.
Yeah, great. Yeah, so we upload all of our knowledge products to our knowledge library, which you can find at globallandscapesforum.org. You can select knowledge, and we organize them by our 5 main themes, which are rights, restoration finance, and food and livelihoods, and measuring progress. So we encourage you to explore those products that we've curated for you as well. One note is that I believe that all of the recordings from this whole conference will be available in about 2 weeks because we need to process them, yeah, make sure that they're usable for you. Yeah, so now kind of getting more into the content of this tutorial. One of the first audience questions was, where can I get the data we would be scraping? I know that you, sort of opened the tutorial with this, and you gave several examples of where this kind of data could come from. But could you maybe just summarize what it exactly means that we're like, what exactly are we scraping when we're talking about web scraping, and where can we get this kind of data? Oh, I think that you are muted, Greg.
It can be done on any URL. So it will depend what you want. I mean, maybe you actually wanted to collect the sort of HTML syntax, and you didn't want any of the text. That's just as possible. In this case, we wanted the text because usually the next step after this is textual analysis. So we could do something like there's another program which you can use, install packages, parentheses, word cloud, and then repository, a website called www.cran.org. And that package will actually allow you to produce word clouds from the text you create. So you can mine the text, as we just did, and then you can create a word cloud of the most prominent words. And there are scripts available on the internet readily on GitHub, which show you how to use that package to use the text that you just created. So there are lots of applications for it. In terms of getting the data, most websites are easily scrapable, and they want to be because that's how search engines function. It'd be very counterproductive for a website to have poor machine readability, because that would actually impact its own search engine optimization. So most websites try to be as routine in their layout as they can, which gives us an advantage because then we can mine it more efficiently.
Yeah, really interesting. I was going to, specifically ask if there are certain website structures that work really well for this, or if there are certain attributes of a website that make it really difficult to use. Can you think of examples of maybe types of websites that people might want to explore that this might not work very well for? Or is this the new age? Is this what's what people are paying
highly
attention to?
dynamic websites with if you want to which are dependent on visualizations, because actually this is what we're mainly doing is text mining. The analysis of images is definitely a work in progress, which is being done by cutting edge research throughout academia. What's available to us at the moment is mainly text. So text low, if there's relatively limited text, that makes it difficult to machine read for us. In terms of good websites, if you wanted to practice this, I practiced it using Project Gutenberg. Project Gutenberg is a repository of all the sort of out of patent books. So you can download, for example, say all of Jane Austen. It's very simple to get that file, read it into R or whatever program you want, and then you can practice text analysis on it. So what we were doing today was mainly just getting the data, but a lot of websites just have it packaged for you. So Gutenberg has actually got a TXT file download, which you can just download straight into R, and then you can produce things like word cloud from Pride and Prejudice, whatever you want, whatever works well for you. Actually novels are a good way to practice. The first instance of this sort of applied statistical modeling I ever saw was actually in a book about Hamlet, and it was a network of the characters, and then it was like it worked out how much they interacted with each other in terms of lines, and so it machine read Hamlet, and then it plotted the characters in a network structure, and then the width of the lines was based on how many scenes and lines they shared in each other's presence. So it has a huge application, not just on the internet. One of the biggest data resources are usually government. So administrative data, census information is really useful for getting good access to. In fact, the US government has an initiative of making data more open. So if you want to look at that, that's probably the best way to train yourself in this discipline.
Yeah, that's really cool. I think you've really highlighted how interdisciplinarily relevant this can be as a tool. That you're using R for this, but you could also use other languages. There was a question from the audience about whether you can use Python for this, and if basically what are the advantages of using R versus Python, and if there are other languages that you think are suitable for this. I know that this is kind of controversial.
Most disputed question in all of, R is mainly for social scientists. Python is for developers, in my opinion. Python does have a version of this. I think it's called Beautiful Soup. So it's like a similar package that you can do. And in broad strokes, everything we did today can be reapplied to a Python console and put in using slight variations in the language. My sense is that it's less useful because the cutting edge research, which is going into building these packages, is more heavily weighted towards R now. So when it comes to really complex algorithmic programs, you're going to get it first through R. So I think, if you look at these institutions at the cutting edge of this, their scientists are writing these programs in R and then they're put into Python. Broadly speaking, academia R, Silicon Valley Python. That's my impression. But it's each to their own. I mean, I saw a wonderful flow chart of it a while ago of what you should choose. But it really is, there's a lot of flexibility now in both programs. So I would try R first if you're interested in this specifically.
Yeah. So kind of taking a step back, talking about using R or Python. If you're imagining, sort of beginner's approach to this, saying, taking people, for example, who have never interacted with programming languages and maybe find it a little bit daunting. Do you have resources that you recommend for people to be able to learn this sort of basic skill or feel more comfortable with this sort of interface in general?
My advice would be to go to repositories like GitHub and use code like the one I just wrote and just copy and paste it. Don't even try to write it yourself. Just copy and paste it and then slowly change things. Like you then put in another blog, not mine, another one. You try another URL, and you just keep trying it until you reach a problem, and then you can go to places like GitHub or various sort of R websites and just post it on a forum. I mean, they're very, very responsive. There's an initiative called Tidy Tuesday, which is what a lot of R scientists use or are participating in. And it's basically just an initiative to produce something like a graph or a graphic using R every Tuesday. So I do it, and it's a great way to get feedback on what you do and watch how other people do it, because then they will then make their code available, and you just copy and paste it. I mean, a lot of coding, this is the great secret of coding, is just copy and pasting it. Organic new code is very laborious to write. So what I just did now is probably the limit of typing it in yourself. Otherwise, very not efficient. So don't be afraid to just learn by doing and learn by copying. It's a bit tricky, but there are some great people like Julia Silge. She's a great teacher of R. She actually works for RStudio. That's SILGE. Julia Silge. She's an American social scientist working with RStudio, and she does great tutorials on it. Go to her website. She's the one who did the Jane Austen tutorial, reading Jane Austen into R. Got people involved. Anyway, so there are a lot of activists out there who are interested in spreading this message. So just get involved with the community and reach out and copy.
Cool. Thanks for telling us how we can best stand on the shoulders of giants and and develop our skills further. Speaking of sort of troubleshooting with potential issues with R, there were two questions in the Q&A function that were quite R specific, and specifically, the first question was, I'm unable to locate R binary by scanning standard locations. What can I do about this? And there was also a question of if it's possible to use Command F to find the A and A, the tags or
Yeah, it is.
the nodes.
It is.
Yeah.
So yeah, what you can do is if you go into the page source, there's actually on the bar of the page source, if you imagine there's the lower half of the page, which is the HTML, in the top right, there's actually a search function. It's not terribly useful because you want to match it with, there's going to be lots of instances of it. I'd recommend if you're looking for something, you can copy and paste whatever it is you're looking for into a search and then look at where it's placed. Alternatively, you can highlight it, left click and click inspect element, which will have the same result of finding it. It's probably more efficient, in fact. Or thirdly, you can use the thing I briefly showed, which is select a gadget, which is basically just is an extension which you can click on something and it shows you the HTML to which it's related specifically. So it allows you to locate it. And in many cases, you can just copy there straight into R. Don't need to worry about looking at the HTML. You just have use select a gadget. I use select a gadget mostly. I don't look at that page source thing. That's just to demonstrate the fundamental architecture. First question, R binary. This is a difficult one without knowing where you are. I would recommend getting in contact with them if there's a sort of the CRAN website actually contains a forum with many quick responses. So if you do have a specific problem with where you are and uploading your particular version of R, which is constantly being updated, so remember to keep it updated. I remember several times uninstalling R because sometimes it just gets itself in a pickle. I mean, that's just it. There's no other way to describe it. And it's doing too many operations and it can't handle it. It crashes. So do be prepared to uninstall it, reinstall RStudio. I'm sorry, I can't be more help. I mean, if they contact me in Hoover, I can do it specifically with them. So maybe direct message me on Hoover. Gregory McGann. My name.
Yeah, nice. And another note about contacting individuals. This has been a question that's come up in the organizer AMA as well. It seems that you need to use the mobile app in order to connect individually. I think that you can respond to messages on the web app, but you'll need the mobile app to actually find somebody's profile, look at it, and send a personal message. But yeah, that's also a great resource, which is another really great reason that Whova's open for this whole year after the conference.
Yeah.
People can sort of go back to this tutorial, look at the script, and come up with their own questions. Yeah, but to save them some time, I mean, you talked about, RStudio, for example, can crash if you're running too many functions, or yeah, what are there other sort of really common errors that you think would be foreseeable for people who are sort of in this learning stage?
Yeah. The first thing is to say frustrating syntactical errors. Like R is a very unforgiving language. If you get one letter wrong, it will just not run it. It will just say error. So you find if you have a very long script and you decide to run a whole argument, it won't specifically tell you what's wrong most of the time. So you have to then go through it again. It's very laborious and very dispiriting. So this is why it's important to, first of all, share your code if you've written effective code, and secondly, to copy it, because writing it is just a road to ruin, basically. So copy it as much as possible, run it, and if it's not running, then break each argument down to little bits and then run each one individually, just in case there's some sort of problem. There's actually a help function. So if you have a command, then you put question mark and then run, it will actually tell you what it does. So it could be that could help. So the first thing is syntactical problems. It's very, very frustrating to use. Trust me, it's a steep learning curve. If you try and do it the sort of organic way. Other problems with R, it is very effective at dealing with large data sets, but it's when your commands come into play that it can malfunction. So you can have it can handle data sets with millions of values. I have a value on my RStudio with 21 million values from Facebook, and if it hurt my computer, it didn't hurt R. So it can handle large data sets, and that's actually its forte. But when you're entering your commands, be very careful about the order in which you do them, and be very careful to stipulate what it is you're doing. This is beyond the scope of this tutorial, but yeah, it's just be very methodical about it. Try and break it up as much as possible. Don't run large. Don't highlight the whole script and then run it. That's a road to ruin. It can be done, but if there's a single mistake, or maybe it's out of order, the next stage of this is you introduce loops. So it continues to do something, and that's how you do automation. There's actually a loop function. And if you mess up the loop function, the whole script could bomb. So I don't advise. So that's where the problems really arise. I mean, there are hundreds of problems. So just look at the forms. So if you want problems, there's no shortage. It would save time for me to just tell you what it does well.
Yeah, fair enough. Just thought, we could flag some things that people could anticipate and think, oh no, don't get too discouraged if
one thing I might add actually is data. Data is very frustrating to read in. If you have an Excel, it sometimes you have to fiddle the file a lot to make it enter the data. So if you have a data set and it says read in CSV, which is what you generally do, like this one was read HTML, generally you'll put in read.csv or read undermark CSV, and sometimes it just won't do it, and that's because there's a problem with the format of the file. So it's a matter of going to the file and then trying to look at how the ending, it might say read CSV, but then you might need to change it to XLS or whatever. That's the biggest problem people have. Once people have got the data on R, generally it's easier. They're bringing the data in is difficult. And the second thing I'd say, sorry, I'm going on, is that once you've scraped data, there's a long cleaning process. So the last thing we did was we got the links and the tags. That data will need to be extensively cleaned to be operable in a network graph. That will need to be extensively cleaned in a way that we didn't have time for. But you would run commands to the effect of excluding this, exclude this, exclude that. You can run commands which exclude anything which isn't a whole word. So those are things you have to do to learn. So the hardest things are bringing the data in and then cleaning it. We didn't go through that today, and I think this tutorial is meant just to give people confidence. That will take a long time and generally be demoralizing. So,
well, hopefully it can, be a process where in little bits people gain the confidence to just try this out. And you've provided an example of how you've faced these similar hiccups, but have gotten to the point where you can provide a tutorial on it. So we've been getting more questions in the Whova Q&A. We have about 5 minutes left, so I'll just select a few of them. One participant has asked, what other applications can we do with web scraping apart from word clouds and network graphs? Are there other analytical approaches or ways to visualize those things that you use a lot, Greg, or that you know of being particularly interesting or common?
So one of the most effective, useful things we do with it is create predictive models. So that's what we see every day when we type in something and it tries to predict it. It's essentially looking at a word vector and saying, this is how it most often occurs. Let's, in this context. So the most prominent academic usage of it is in prediction. And there are packages you can upload which provide this in a sort of compact way. The question was that there are other ways of visualizing, was it?
Yeah, I mean, if there are ways to visualize the data, for example, that or what you've analyzed. Another way that this question has been phrased in the Q&A is actually, what are some of the more interesting uses web scraping can have other than what we've seen, for example, to tackle interesting questions relevant to landscapes or conservation?
So message discipline is one of the most important concepts. I mean, this is a specific example, but in politics, one of the most important things is message discipline. And that involves the use of certain resources like, say, hashtags or phrases, stock phrases, certain terms. And web scraping allows us to gauge whether these terms are being used widely. And so if you have a sufficiently large data set, you can see how websites have adopted these terms. That would be a large exercise, but what we can do is we can scrape something like a page, and then we can put it into a program which compares it to an existing taxonomy. So what I mean by that is, famously, there's an R program called Wordfish, which allows a text to be evaluated on whether it's left or right wing, and it compares it to sets of keywords. And it's not precise, but it's a very efficient way of gauging how where it's positioned roughly. So if it's using specific words in specific ways, we're thinking sort of dog whistle phrases, if that makes sense. Things which have a specific meaning to a specific population. Web scraping can pick up on that very efficiently. So a lot of the research that's being done now, one of the most cutting edge research being done by social media giants, is on the study of extremism and the way in which not just information spreads, but language changes and how that language can actually predict behavior. So Facebook is funding many studies around the world into this subject. I mean, they've given millions to countries in the global south to try and build up this research base on the linguistic basis of extremism, for example, and actually studying the global north as well. So yeah, that's another application. There are lots of there are as many applications for web scraping as there are for words. So wherever there are words, web scraping can inform that analysis.
Yeah, great. It sounds like that's, really useful for discourse analysis, looking at the rhetoric that exists in the vast world that is the web. It sounds like that's a really good tool for people to be able to critically look at news sources and other sources of information. Somebody said in the CIFOR hosted leveraging data for transformative change session yesterday, data is not neutral. And this sounds like a good tool to be able to look at it critically and be able to assemble it. So we're already at, my time reads 11:59 of just 1 minute before we're supposed to end this session. Greg, thanks so much for giving this tutorial and for fielding our questions. If you continue to have questions about this tutorial, you can continue to post them in Whova. I would also encourage you to bring the conversation to our Measuring Progress Learning Track social group so that others who maybe didn't tune into this session can hear your thoughts and maybe what you might have gained from this tutorial, where you still want to learn more. So thank you all so much for joining. And I hope that you continue to enjoy this conference.